Okay, is that up and running? Not quite. Warming up. So we have 5 major types of solubility type problems. And then there's one like little baby type at the end that is trivial and really you don't need to worry about it too much. Did you forget your glasses? Oh, that's so cute. Okay. It is on the paper in front of you too, so. I know. It will all be up online, so yeah. Oh dear. What's your prescription like? All right. Your progressive though, so it's a little weird if you look downward. I mean, that's practice. No? Don't worry. Okay. Huh? Our prescription, it's not very much. It's like 1.5 or something. What? It is, no, I used to have, I got the laser eye surgery when I was in my 20s. And it lasted for like 20 years, so that was great. But then after 20 years, my eyesight started to degrade again. So now it's like, it's not too bad. I mean, I can wander around the hallways. I wouldn't want to drive, right? If you see me though in the hallway and you're like, and I don't have my glasses on, you're like, hi, I'll be like, who are you? Yeah. So, anywho, so I think what we're going to do is we're just going to go through these a little bit, but mainly this is a reference for you. Yes? So in the type 1, there's no particular reason that this is type 1. It's just they needed to be a type, and this was the first one I wrote down. It's given the solubility, find the KSP. So you will be given a molar concentration, and you'll be asked to find the KSP. These are usually pretty straightforward because it will say, find the KSP, or it will say, calculate the KSP. So this is really easy to recognize, yes? And I have written down all the steps that you need to do for the written response, but we have already gone through those. I don't think it makes sense to repeat them at this point, okay? But they are here for your reference. There is a little bit of an extra thing that you can do for the multiple choice. Not for the written response. If you do this in the written response, you will not receive full credit. So sorry, you will not get all the marks you can get. But for multiple choice, I don't know if you guys have noticed, but for every salt that is an A-B type salt, that's a 1-to-1 ratio, if you let the solubility be X, then the concentration of A is X and the concentration of B is X, yes? And the KSP is X times X, which is X squared. So turns out that if you know the KSP, the solubility is the square root of KSP. Yes, or if you know the solubility, you just square it to get the KSP. So for a multiple choice question, that can be a real time saver. Yes? You can do the same thing for a 2-to-1 ratio compound. So let's say that you had, do I have room to write it there? No, I don't. So we'll write it over here. If you have a compound which is A2B, I'll write it bigger. If you have a compound that's A2B, better? And it's in equilibrium with 2A plus B. And if the solubility is X, then that means that 2A is going to be 2X and B is going to be X. And that means that our KSP which is going to be A squared times B that's going to be 2X all squared times X. Yes? And if we take that 2X and we square it, what do we get? What do we get when we square the 2X? Yes. We get 4X squared, and then it's times X. So we will always end up with 4X cubed. So again, if you're doing a multiple choice type question, you know that KSP is equal to 4X cubed for any salt where you have a 2-to-1 ratio. Yes? If you're like, okay, that just confused me, you never have to use that. Are you allowed to just plug this in as a formula in the written response? No, you need to show this kind of work, yeah, on the written response. So, but can be very helpful. You could also, if you wanted to, even have an a 1-to-3 ratio, but you don't come across those that often. I think it's easier just to solve for it. You know what I mean? Like I think it's 27x to the 4th. Yes? But yeah, whatever. Anyway, that's just something useful that you can use. There are some examples down here at the bottom, and I want you to see if you can spot the question type. Can you tell that these are a find the KSP kind of question? And remember, this is the easy one. Look what that first one says. Calculate KSP. Yes? Oh, and did I give you the solubility? Well, I gave you some grams in some milliliters. Could you find molar solubility from that? Yeah, okay. What is the KSP? Oh, look at that. And again, you've got some moles and some liters. Oh, what is the KSP? So this one's really easy to recognize. So just, and it's a pretty straightforward thing. Because there is only one compound, is this dump and stir or is this mix and match? Dump and stir, so your ions will be proportional to the coefficients. I think it says that at the top. And I put this note in here because so many times I've gone through this, and these examples are really just meant for you to kind of look at and get the idea. This is what these types of questions look like. However, I've found over the years, a whole bunch of students will solve them and they'll be like, where's the answer key? And I'll be like, there is no answer key. They were just for looking at. But I got so many requests for it that I made an answer key. So you will, if you do want to do them as extra, you can, but that's not what they're there for specifically. Okay. But I mean, if you want it, the answer key is there, okay? But they're not meant to actually be done specifically. I'm not assigning them is what I'm saying, okay? All right. Type 2. This is the reverse. Given the KSP, find the solubility. And the only tricky thing to remember here is don't just look up the KSP and say, oh, that's my solubility, especially in the multiple choice. That's a tempting thing to do because is KSP solubility? No. You need to use KSP to find the solubility. And remember, if you're doing it in multiple choice, if I give you a KSP and you have an A-B type compound, what's KSP equal to? X squared. And what if we had an A2B? Yes? Equals 4x cubed. But if you forget that, you can always, you can always solve for it, okay? So spotting the question, you're gonna look for words, find the solubility. Oh, that one's pretty straightforward. Find the concentration of a saturated solution. Because guess what? What is solubility? Those two are the same. What mass of AB will dissolve in a given volume of water? That one's a little trickier, yes? However, if you think of this as a dump and stir, how much can I get to dissolve in a given volume of water? That's going to be my solubility. So that's going to be my grams per liter, and then I'll convert it to moles per liter. What is the concentration of A in a saturated solution? If you know the solubility, then you can find either of the two ion concentrations, yes? Because you know that they're proportional to the coefficients, because again, this is a dump and stir kind of question. And now for the one that makes me sad, because you remember how I was like, oh, it says maximum, that's a max min problem. Super easy. Well, calculate the maximum amount of a low solubility salt. It won't say that though. Okay, you'll have to figure out that it's a low solubility salt that can be dissolved in a particular volume. Okay, and that's not, what's the maximum I can get without a precipitate forming? That's what's the maximum I can dissolve. So that would be looking at the concentration of a saturated solution, which is your solubility. So they do start to require some good reading skills, reading comprehension and analysis. I know, imagine that. Okay. There's a bunch of stuff, blah, blah, blah. Can you recognize that this means find the solubility? And remember solubility. Why is my pen not working? I just put a new battery in you. There we go. What would our unit be there? And that is a unit of solubility. The next one's really easy. Calculate the molar solubility. Oh, I like that one. The next one's also not bad because it says it wants the concentration of a saturated solution. And we know that the concentration of a saturated solution is solubility. Oh, and this one says, what is the solubility? So it's not too bad. When you have a question like this, what should be the first thing that you do if you're finding the solubility? Let statement, yes? Okay, and it actually does remind you of that up here. Okay, and that's the one where you write the x's underneath your equation in the stoichiometric ratio. Okay, so that's type 2. Type 3, given KSP and one ion concentration, find the other ion concentration. These are minimum maximum problems. Remember I said minimum maximum problems are pretty straightforward because you're going to be given a KSP, you're going to be given an ion concentration, you just solve for the third one. That's what these are, okay? So you're going to be looking, and we did pick out those words, yes, was it yesterday that we did this? Maximum, minimum, just barely starting precipitation, right? Remember, we're just tipping over. Oh, what's the maximum we can have without precipitating? What's the minimum required? Yeah, okay. And don't forget, because this will involve two compounds, or possibly you'll be given one ion concentration and you'll be asked for the other ion concentration. That means you need to identify the precipitate because this is mix and match. Will your ion concentrations be proportional to the coefficients? No, because it involves two different compounds. So some are coming from here, some are coming from there. So the numbers are just whatever you happen to put in there. Let's take a look at these. What is the maximum? Oh, there we go. What is the maximum concentration of lead possible in a 0.1 molar solution of sodium chloride? Do you see how that's different from what's the maximum number of grams that could dissolve? Right? This is the maximum possible that we could have. A saturated solution of strontium sulfate has a concentration of sulfate of 1 times 10 to the minus 4. What is the concentration of strontium? This is a particularly nasty question. If you get one like this, I am so sorry, because doesn't this sound like dump and stir? Right? Because we've only mentioned one compound, right? And wouldn't we love for it to be exactly the same? But it's not necessarily, right? Because we haven't said I created a solution by dissolving strontium sulfate. You're going to have to use your KSP and this ion concentration to find it. So I'm sorry if you get a question like that, but I'm warning you that it might happen, okay? Most of them, though, will be easier to spot. The moment a precipitate starts to form, okay? Without a precipitate forming, what type are we on now? Type 4. Oh, these are Q. Q is nice because if it says will a precipitate form, unless you are given 0.2 molar concentrations, what happens if you're given 0.2 molar concentrations? Those are big, high concentrations. you will just use this one. Yes, if your concentrations are large enough, 0.2 molar or more, you will just use this one to say a precipitate will form based on whether it's soluble or insoluble, okay? However, if your concentrations are smaller than 0.2 molar, why are we back at the beginning again? Always a mystery. Sometimes it goes back to the right place and sometimes it doesn't. Anyway, you'll have two compounds mentioned, two ion concentrations mentioned, and it will say, will a precipitate form? So again, it's a mix and match kind of problem, so you need to identify who is the precipitate. Anytime you've got two compounds, I'm not going to be asking you probably about the solubility of one of those two compounds. I'm going to be asking you about the solubility of the precipitate that forms between them. Oh yeah, in multiple choice, you should just be aware. I think you're good with K trial for Q being used sometimes, or trial KSP. Sometimes you'll also hear it referred to as the trial ion product, or even just the TIP. Okay, so just be aware that those are all out there. So number 12 and 14 are really easy. Will a precipitate form? These are mixed. Added to, will a precipitate form? 13 is a little trickier. A solution is found to have an initial concentration of lead of blah, 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 and a concentration of bromide of blah, blah, blah. What will be observed to happen as the ions interact? What could possibly happen when ions interact? You could either get a precipitate or you could get no precipitate. So that's what that question is asking, but you kind of have to, interpret that a little bit. Just two more to go, and the last one's trivial. And number 5 is a titration question, and it should say titration, titrate. There should be mention of a burette or something like that. You know what I mean? It's pretty obvious when it is a titration. And we just went through how to do those. Titration, titrated, not much to go through there. The last type, we didn't even bother learning this because it's so straightforward. If I give you an ion concentration and another ion concentration, and I say that it is at equilibrium, could you find KSP? Yeah, you just go A times B. Yeah? That's why it's really hard to even find examples like this because it's pretty trivial, okay? We've got a certain solution contains this molar and that molar. Find the KSP, just multiply the two together, okay? So what you can do at this point is there is a problem set on the next page, and it includes one of every type except for type 6, okay? So you can go through this and you can be like, okay, can I recognize the type and can I use the correct tools to do it? If you don't feel ready for this yet, you can go back to the previous worksheets and do like a little practice on each of them. You know what I mean? Like you could go back to 3.2D and do a practice problem or two, and 3.2E and so on and so forth, and then come back to this. But if you feel like you're ready, this is what you're going to be doing over the weekend. And if you run out of these and you're like, I really need to study for this quiz because it's a big quiz, 3.2I is more of the same. Yes, they're all just jumbled together. And if you run out of that, there's a 3.2J, but I don't have a worked answer key for that because there were 20 questions and I just couldn't do it. Okay, but there are answers, there's just not worked answers. So you have more than enough. If at minimum you should be doing 3.2H, but it would be a good idea if you have a little more time to do at least some of 3.2I as well over the weekend. Okay, and that's it. I have nothing more to teach you in solubility. So we're done the unit. This is next week. Our test will be the week after that, probably during a long walk. Okay. Yeah, no, it'll be okay because they're all oxidizers. So yeah, it shouldn't give anything away.